So I'm going to read out 3 statements. Do any of these apply to you? So scenario 1, you wake up in the morning and think, yes, let's do some vectors. Scenario 2, you're sitting there in class thinking, I wish we could do more vectors. Scenario 3, you see a vectors question and you think, this is so easy, I immediately know what to do. Well, none of those scenarios fit with many people at all, as it happens, okay, myself included, okay. No one thinks, yeah, let's do vectors. It's one of those topics where, you know, it's not really anybody's favourite, okay, it's just there, you know. And also, you get a question and unless you're extremely good, you don't really know what to do straight away, okay. So just bear that sort of thing in mind, okay. So lesson 1 is, whenever you see a vectors question, don't think, oh yeah, I immediately know what to do. That's not going to happen. Okay? So even this question here, you're not going to necessarily know exactly what to do. Okay? So we've got to try and find some steps to make things easier. Breaking things down. Diagrams are the key to understanding vectors. Okay? If you think about graphs, and how graphs helps us to understand problems involving tangents, normals, gradients, intersections of lines. Okay? Even sketching a graph helps us to understand what a function is doing. Well, without those graphs, we wouldn't be able to understand as much algebra as we do. Same with vectors, okay? We need diagrams to understand exactly what's going on, okay? A simple example. It's an example that shows you how vectors is actually quite useful as well. So we're given coordinates of 3 points, P, Q and R, and we're told that PQRS is a parallelogram. Okay? Our objective is to work out what the point S is. Okay? Something like this. Okay? Draw a parallelogram. Okay? Try and make your work as simple as possible. That's what I always do. Okay? I try and make a question look as simple as possible. All right? So I'm going to draw a parallelogram. P, Q, R, S. Another hint for you. When you're joining the points up of a shape, they always come in precisely that order, P, Q, R, S. So start with P and then go Q, R, S. Right, I'm going to label the points. So P is 4, negative 9, negative 3. Q is 7, negative 7, negative 7. R is 8, negative 2, 0. Okay? Is it already feeling a bit easier? Okay, just having that visual representation is actually useful. And then just think, what do we know about parallelograms? What do we know about them? Okay, well, they're called parallelograms because you've got 2 pairs of parallel sides, okay? So you've got those are parallel and those are parallel, okay? And we're going to use that parallel fact to try and help us to answer this, okay? But what else do we know about parallelograms? We know that side and that side, they're equal in length, and this side, they're equal in length as well, okay? In terms of a vector, you should find it easy to be able to work out what the vector QR is. Okay? The vector QR describes precisely how to get from point Q to point R. Okay? And all I'm doing is talking about coordinates for the time being. Alright? So what I'm going to do is I'm going to write it as a column vector like that, because that's my preference when I'm dealing with vectors using pure mathematics. I don't enjoy the IJK notation. Okay, I leave that for mechanics only. Alright? So you've got from 7 to 8 is an addition of 1. From negative 7 to negative 2, that's an addition of 5. And then negative 7 to 0, that's an addition of 7. And I'm going to check that, okay, by doing 7 plus 1, yes. Negative 7 plus 5, yes. Negative 7 plus 7, yes. So QR is vector 157. Okay. Now I can use that to help me because I know that that must also be the same as this one there, P to S. Okay, these two are exactly the same vector. Okay, they're exactly the same vector because how you get from here to here is exactly the same as how you get from here to here. Alright. Now we know that point P is that, okay, 4, negative 9, negative 3. So to get from point P to S, we're going to do 4 plus 1, which is going to be 5. And then we're going to do negative 9 plus 5, which is negative 4, and we do negative 3 plus 7, which is 4. That is it. Okay, that is it. There's no magic that's needed. Okay, it's just a little bit of understanding what's going on. okay? And that understanding really came from drawing the diagram, okay? At what point did this question suddenly get easy for you? Just ask yourself that question, okay? I bet it was sometime well after the diagram was drawn, wasn't it? Anyway, that's my first example.